Hi, everyone. Welcome to another episode of our podcast, Tech Talk, a podcast where we talk about various technology related topics and deep dive into one of the topics that we choose each week. Please feel free to subscribe and have a look at our past topics. We had a number of guests before and talking about various interesting topics in the past. Today, we are going to talk about robotics. Robotics is a very exciting topic for both of us. Amit and I both started our journey and did our degree in mechanical engineering. And in engineering, there is a lot of opportunities to be involved in robotics. Somehow we sort of swayed and came into IT, but robotics is a very interesting topic because it combines the IT or the sort of the software engineering and physical engineering, which is mechanical, together to build something very exciting. So yeah, robotics. Very excited to talk about robotics today. Uh, Amit, what's your thought and what do you think about robotics?
Thanks so much, Rinat. I think, yeah, you're right. We both did mechanical and we are both familiar with robots. I've actually taken part in a couple of technical events in uni where we built robots with a couple of my friends at uni, and it was quite fun. I remember we built a robot, the line follow robot. And then there were other robots where we had to carry some weight across a stream of water with propellers, etc. So we use microcontrollers, etc. So yeah, I'm quite excited to talk about this subject. I'm sure some of my college friends who are listening might be excited about that as well.
Yeah, absolutely. You just reminded me. Also, yeah, when I was doing my degree, I was also, making number of robots, and sometimes, I mean, in the first year, it was just the physical body of the robot, and then as I moved to second year and third year, I was also doing the software side of it to make it move. It was very exciting. In my postgraduate thesis, I did a robot which will map a whole surface, like electric vehicle kind of robot, which will look for obstructions and try and find a new path, avoiding all the obstruction it comes across. So yeah, I made it with Arduino, and yeah, it was really exciting, and yeah, it's good to think back to those days as well. Really exciting projects, really cool things you can do with this kind of technology.
Exactly. So yeah, I mean, let's dive right into it. So, what do you know about robots? What do you think a robot is for the benefit of all our viewers and listeners?
Yeah, of course. So what is a robot? I mean, when we say robot, we immediately have like a view in our heads because, by looking at various science fiction movies or looking at or reading science fiction novels, we kind of have an idea of what robot is and, what to expect when we talk about robot. But actually, in real life, there could be many different types of robots, which maybe not shown in science fiction movies or novels, but in foundationally, robot is a machine. It will have a physical structure. It could be looking like human, like humanoid robots, or it could be looking like something, not in any way related to human, or it could be like looking like parts of human, like arms and things like
Yes.
that. Um, so it could look like various things, but at the end of the day, it's a machine. It's like a physical machine that can be moved by software programming. So you create or design something physical for whatever purpose you're trying to achieve, and then you have to be able to move it. And to move it, you have to have some sort of software programming injected right into it, and that software programming or the programming that you put in will know what to do or how to move the physical product itself. So I think that's the robot, a combination of a physical structure and software program which will move the physical structure in any way that is required.
Okay. So yeah, that's I think I mean, that definition, yes, it gives a brief overview. From my experience, I think robots are exactly that, machines that can do tasks or actions or some kind of activity by itself or through some human control. So on an assembly line, you have these mechanical robotic arms that you see in a lot of videos where, say, a Tesla is getting manufactured and there are these robotic arms that are doing the welding to connect
Mhm.
different parts. That's a very repetitive task. So actually, robots was initially designed to do repetitive tasks, just like we use automation tools to do repetitive tasks in software. We had robots to do heavy lifting as well as automatic tasks, repetitive tasks um, in real life. And I think that is quite important, because that frees up a lot of time and energy for humans to do some other activities. And uh, and yes, they can be programmed by a computer or a microcontroller. That's what an Arduino is. So I remember in our engineering days, we used a microcontroller and then just program that, so connect it to a computer or a laptop, and then just write a code, say C++ code, or there is assembly language as well. So program that and then get the actions. But of course, a robot itself is built up of different parts. So we talked about the machinery. So it's a physical part is all machines, metals, or plastics, etc. Gears, actuators, motors, etc. And then you have the electrical part, which gives it power, energy. So a battery or something like that, that gives it energy to run, to move. And then finally you have the controller with the program, so that's the software part. So all these three thing together combine and make a robot, and that is robot. But then what is robotics?
Right, of course. Yeah. I mean, to be honest, I mean, just thinking out loud, anything to do with robots is robotics, of course. But yeah, I mean, if you want to dig a little bit deeper, it's a technology altogether. It's a branch of technology that that deals with, it automates things in one way or another, or augments something that a human is trying to do. So yeah, it's a technology that basically deals with anything to do with robots, design, construction, operation, and also looking at the computer systems for their control. So yeah, robotics is, in a nutshell, anything to do with robot, the branch of technology that deals with robot, and looks at what can be done and how to automate any particular objective or process that humans are trying to augment or replace. And I suppose that's what I'll call robotics. What's your thought on that?
Yeah, I think it's similar. So you have robots, and then there is a field of building robots. So how do you design a robot? What is the problem that you're trying to solve with building a robot? So the whole idea of building a robot, constructing it, designing it, and then developing it, programming it. So all those things. So mechanical engineering, electrical engineering, computer science, mechatronics, electronics, all these combined fields to create a robot that solves a particular problem. I think that is robotics. So the field of doing all these things is robotics. So moving on from robots and robotics, I mean, we are talking about robots because currently in our day-to-day life, we are familiar with using a lot of robots without our knowledge, like a robot vacuum, uh, the Lego the Lego bots that come. So you can actually there are toys now that are small robots that you can play with. Drones are in essence a robot. And then you have those remote controlled cars, etc. They are doing some task based on some control from a human being, so we can classify them technically as a robot. So I mean, that's why we chose this topic to talk about today. And also, if you notice the news, then recently NASA launched a rover on, landed a rover on Mars. China also did successfully, and those rovers are being controlled by human beings on Earth, and they are sending signals, and they are asking the rover to perform certain actions, and that in essence is also a robot. So it's performing certain tasks, moving around on the Martian surface, and sending back feedback to humans back on Earth. So 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 that's why it's a very relevant topic, and it has far-reaching applications. So from your experience, because I know you have worked in automotive sector and you've worked with machines, what's your experience like with robots, and what have you seen that are the possibilities of using robots?
So yeah, I mean, while I was working as mechanical engineers, I've designed a few robots myself, and I've worked with many robots, and I've seen in assembly lines there are so many robots. As you mentioned, in like in Tesla, they're doing the welding, but in all assembly lines, anything that is nowadays, most of it is automated. And I've seen, like, even in food processing as well, when you have industrial food preparation, all of these are done through assembly lines, and there are various robotic arms that are moving and doing the repetitive tasks. That is really cool to watch as well. I mean, there's a TV show called How It's Made. I watched that quite
I've
quite
seen
a
that.
lot. Yeah, it's quite interesting to see how, when things are made in mass, that obviously whenever you're buying a product, you either see whether it's handmade or not, because handmade has some sort of value, because the ones that are not handmade are is actually robot made. And, those are actually amazing to watch the how quickly and how efficient a robot can be when it's doing something repetitive. And yeah, I mean, in automotive as well. I mean, automotive sector, I've seen robotic arms doing various parts of the assembly line. And one of the cool part is that these robotic arms they're not always arms, or they're not always the arms that shaped like that are shaped like arms. They're, various differently shaped robots. But the cool thing is that a lot of the times these robots functions are easily programmable. So you might think that, oh, this is a robot. This has been, the software program is for it to do something, maybe to screw a bolt onto a surface. But the same robots, you could upload another, piece of code or software program which will do a completely
Different task.
different task, different action, and with the same level of efficiency. So that is really fascinating to me, because if it is transferable very easily, then that is one of the biggest limitation of anything to do with physical products or physical robots. That you're if you have to have one robot for one type of task, then it becomes very costly. And obviously one of the main reasons we're you know talking about, or finding robots as a technology, is to decrease cost. So the transferability or the adaptability of robot is very important, and that's what I've seen in assembly lines, that same robot is maybe bolting a screw, and then it's spray painting a surface and
Yes.
things like that. So yeah, quite different type of task, but as long as it has the hardware ability to move, and move and be able to access different parts of whatever product it's working with, it can do various operations. And that's kind of when humans developed opposing thumbs. So with our hands we can do various things, but we had to have the opposing thumbs to be able to hold things, and then the amount of things we can do has suddenly increased. um,
It's interesting that you mentioned the opposing thumb, because I also feel that without a thumb, it's very difficult for humans to do any complex task, especially holding objects like holding a tool, holding a gun, holding a firepower, whatever. I mean, it's important that you have a thumb, otherwise it's very difficult to operate machinery. And I think that has transformed, and it's one of the key reasons of success for human beings. We vastly underestimate the power of a thumb.
Yes, yes, absolutely. I mean, while evolution has given us many, many benefits, but then when you look at robotics, you also think of ways how evolution failed as well, if you think about it, because after millions of years, why do we still have legs? Why don't we have wheels? Because that would have made transport and going places so much more quick and efficient. But interesting thing is the evolution works in a different way. You have to have incremental increase of performance. In order to have wheels, you probably have to have an axle first, which will hold the wheels, and that would never happen in evolution. So this is actually a good comparison between robotics and how humans evolved, because we think that after all of them, we don't have to even think about humans. The whole evolution process of various animals and things like that. They evolved after millions and millions of years. Whatever shape that we've ended up is actually, the best one because,
Yeah, over a million years, we have evolved into these complex beings that have
yeah,
mastered planet Earth, that are ruling planet Earth.
yeah, that's good. That's all good. But we have to see that the process of evolution is, it has one focus, which is incremental increase. It has to change very small every time in every generation.
Yes.
And if those small changes have to have some benefits. So you can't have a, a system where you sort of plan that, okay, I'll have this complex feature, but to get to that complex feature you have to have smaller changes that doesn't do anything, and then you'll end up with a complex something that will never happen in an evolutionary system. Because as I was saying, the reason we don't have wheels or better way to transport is because all the small things that are required to slowly evolve, it wouldn't bring any benefit to that generation. Robotics, this is where robotics comes in, and we could think of things that we would never think in evolutionary design, because for example, wheels are quite quite useful.
Useful,
And
yes.
yeah, and we could add robots. There could be humanoid robots, but instead of legs, they will very likely have wheels, because that is so much easier to move around.
Move around, yes. I think limbs give you an advantage when it comes to stairs and climbing objects, but with wheels, it's easier to navigate multiple terrains quicker and faster. So I think that's what you see in science fiction films, where you have a combination of wheels and limbs, where you use wheels to go on a flat piece of land very quickly, but then you need the limbs to climb above certain things, like climbing a mountain, climbing stairs, etc. And I think it's very interesting where you compared the evolutionary aspect with robotics, because I think evolutionary process is very slow process, and it's very I mean, it takes a lot of time. With robotics, what we have done is we have outsourced all the problem solving parts to a piece of machinery that can do it 1,000 times quicker, maybe 100 times quicker. And we are able to so the thing with evolution is you have the environment, and then you have an impact on the organism, and based on that impact the organism adapts. Now with a machine, the adaptation can be far quicker if we get feedback very quickly. So suppose I
Yes,
do something a million times, I get a quick feedback, then I change it, and then I do it another million times, and then I get more feedback, I adapt it. So I'm actually evolving just like humans, but at a much faster rate. So that's why we have seen more progress in machines, computers, software, hardware, electronics in the last, say, 2 decades than in the evolutionary aspect of human beings or animals.
absolutely, absolutely. I mean, feedback is so important to any robotics. I mean, this is one of the things I was going to bring up as well. For whenever we talk about robotics, we have to talk about feedback or input, data input.
Yes.
And Yeah, I mean, even when we were talking about like what is robotics, I was thinking that yeah, we talked about the main two aspects are hardware and software, but if there was to be a third main thing in robotics, that is the data input. It needs to have a way to get information from outside. That could be a human giving the information, like in a drone. You're using a remote control. You're sending information into it, or it could have a camera or various other sensory devices, which will, like the Mars rover, that is not that real time controlled by a human because we are 11 minutes away from Mars. Even with the fastest communication technology. So um, in Mars, they have to have various sensory technology. We've already seen a lot of pictures that come through. So there are various camera, and then there are infrared cameras. There are different types of cameras which will sense different kind of things, and then there are other sensory devices that would understand the weather, the humidity, and all of that thing. And then based on all of that, it can then make a decision and decide what to do. I mean, yeah, robot is a thing that can move about, but what to do? And without that information from input, it wouldn't know what to do. And that I would say is a third sort of pillar of robotics, if you'd like, to have the input. And whenever we talk about input, there is this opportunity for us to give it feedback. And if it can, I think nowadays obviously the robots are becoming more and more integrated with AI and stuff, but I think one of the main thing is for it to remember the feedback that it received over a period of time. So if it can remember things and change its course of action based on that, then it kind of is an artificially intelligent robot, if you think about it, because every feedback you give it over a period of time throughout its experience, and if it can remember and combine all of that experience and then base its action on it, that would be instantly quite an intelligent robot.
It's interesting because it's like a self-learning robot. So you keep letting it do things, and based on that it learns and then it remembers. Because human beings also learn a similar way. We retain the information as an infant, as a child, and then over a period of time we add on that information. And that's why they say, right, experience makes a man, and every man or every human is different because we have gone through different experiences, and that's one of another reasons for our success as a species on this planet. And I think this whole idea of feedback is, I think, very crucial as well, because if you look at autonomous vehicles, where say Tesla is developing this autonomous capabilities, without sensors it's not possible. So you have to have the cameras, the radar, the temperature, pressure, humidity, whatever sensors you need to clearly see what's ahead of you, predict what will happen next, and then based on that take certain action which is there in your algorithm. And the more sensors you have, the the more data you collect, and the more data points you have about a particular situation, the more informed decision or more accurate decision you can make. It's like a statistical analysis, right? If you have more data points, you have better accuracy for the prediction, and I think that's important. And let's move on. I mean, for me, I think robotics is assembly line, because that's where you see the biggest benefit, and everyone sees the biggest benefit. The assembly line where you can manufacture smartphones, laptops, bottles, glasses, beds, furniture, heavy machinery very quickly in mass, and having sufficient quality. Say Toyota, they manufacture so many cars in a day, and all the cars, they are I mean, I'm sure humans may be involved, but majority of it is, I think, on assembly line, controlled by robots, painting, welding, assembling, and then high quality, high availability, and less errors. And I think that's also important, because without the production capabilities on the industrial scale, it would be very difficult economically to I mean, have robots in the first place. Because I mean, of course, there are other industries and other areas where robots can be used, say the space exploration program, but I think the manufacturing or the industrial use of robots is the highest.
Absolutely, yeah. That is what it is at the moment, and that's bringing us so much benefits. It's nearly unmeasurable because yeah, I mean assembly lines, how fast the robots work. It just amazes me every time I watch it, and yeah, I mean, and then but then obviously nowadays there are also like a lot of cool applications as well. I mean assembly line is bringing up us the biggest benefit of robotics, but then nowadays a lot of hobbyists and people who are like makers and stuff, they're making their own like sort of individual robots for doing something, maybe something cool. I've seen a YouTube video where this robot just follows someone around the whole time, and then maybe tells the weather and things like that. And it could kind of you. It's interesting how quickly you could make a complex robot, but just by combining existing technologies. So if you sort of integrated an Alexa or a smart home speaker into a humanoid robot, it could kind of very closely resemble like a modern day like a humanoid robot that talks to you, right? It
Yes,
will be able
yes,
to do that.
absolutely.
So yeah, that was very cool project to watch. And then there are well, this one's not necessarily a robot, but I've seen a mirror, like a smart mirror, which is you can use it as a mirror, but you could also as a like a background, like by pressing a switch the mirror would turn into a screen and it will give you weather information and the latest news and stuff like that.
Yes, I've seen that. Yeah.
Yeah, yeah. So there are very cool applications of all of these things. And one of the things that we have to mention if we talk about robotics is Arduino, and it's like a open project.
Controllers, yeah,
Yeah,
microcontrollers. Yeah.
yes. I mean, it obviously has IDE to write the software code as well. So yeah, I mean, that's one of the things that you would come across if you are trying to build a robot yourself. It helps a lot. You have the hardware and the software under one thing, and one of the things that a lot of the time, I mean, I was really afraid of when I was doing my degree and stuff, is that, oh, I don't know how to write a code, or even if I do, I don't know how to write it very well. But I would urge our audience to think about to know that you really don't need to know a very like like a professional standard coding knowledge to build robots, because most of these actions are actually already coded by someone and is available. Most of the things I've done in Arduino, I actually copied from other people who have done similar movements. So that's the thing about robotics, that there are movements there are similar movements that makes up a whole series of complex actions.
Yes.
Ultimately, a robot could be painting a complex piece of, I don't know, a car part. You're thinking that, oh, it has to know all of the surfaces and then spray and then, stop and stuff like that. But all of these are actually can be like broken down into smaller movements that each of the motor will do, and those are coded. So you just have to combine, assemble different pieces of code from different places, and voila, you have a complex robot doing very complicated series of actions. So yeah, definitely worth checking out, and not be afraid or reluctant thinking that you don't have the knowledge, because most of it is already done. You just need to assemble it to create something actually very cool and advanced.
Interesting you say that because if you think of Lego, it's a similar concept, right? I mean, you have a Lego car and you think, how can you build this car using all these small tiny blocks, the Lego bricks, and then using those small things, you create a very complex object. And the same thing is with evolution as well. Everything starts with, if you look at the atomic level, you just have proton, neutron, and electron, and using those as the building blocks, we have humans, we have computers, we have different machinery. And then if you look at IKEA, the furniture, so they have packed boxes. And if you think like, how can this flat pack become a bed or a sofa? And then you start building it together, and voila, it's a bed, it's a sofa. So yeah, you're right. You have to break down everything and make sure that yes, I mean, solve that bit first, and then move on to the next bit, and keep on adding incremental upgrade, and then slowly you can solve more and more complex problems.
Yes, yes, absolutely. I mean, this brings me to the other thing about the purpose of robotics. I mean, we have various robots with in assembly line, and in various other places. So, what are the reasons that as humans we came up with this technology of robotics? It's usually to always solve a problem. There
Yes.
was one problem in there were problem in industrial, after industrial revolution, humans were doing a lot of assembly line, but we needed faster, we needed more products, so we needed more efficient way of going through the assembly line, and then we created robots to help us with that. And but that's not that, I mean, that's one purpose, but usually there are many problems that needs solving, and depending on the kind of problem you want to solve, the shape or the type of robots also change. A lot of the time, say for example, we want to go say mining, precious metals and stuff.
Yes.
You need to go thousands and thousands of feet under the underground and things like that, and then you might have to move heavy rocks and things like that. And also it's very risky for human life, because the ground could collapse, and people could die, etc. But this is where exoskeleton or sort of augmented robotics kind of come into play, where a robot is being controlled by a human up, on the surface of the ground, but the robot itself is being sent down the cave or the underground to do various stuff. And the human can see through the camera that is attached to the robot what the robot sees, and then move their arms and limbs, and the robot replicates those tasks in underground, and then that way, without risking any human lives at all, and a lot of task is being done. And also, not only that, but robot brings in a lot more strength. So if the human, if they were sent underground, they probably wouldn't be able to move a rock out of the way, but a
Yes.
robot could. So I mean, a good way to look at different robots is probably looking at the Avengers cinematic universe. So different.
Or Transformers.
Yes, yes, yes. So I mean, coming back to, I mean, looking at Avengers, I mean, Iron Man, that's a robot. To begin with, all the things that Iron Man does, augmenting the performance, human performance, including flying and things like that. These are all being done by a robot. Obviously, the energy source is a bit of a gray area in real life. I mean, but apart from energy source, everything else that is shown is very much possible with robotics. That is robotics, and that can be done in current technology. The only thing is the arc reactor and the power source. Having such a small power source to power such a large amount of activities. But apart from that, I've seen like Iron Man masks, which kind of opens up and closes down, and it's very cool.
Yeah, I
But
think
then,
the heads-up display that Iron Man has with everything, it's like augmented reality, right? So you can have a glass, you can have a helmet, and they'll show you all the display about what's happening, who's in front of you, and maybe do a Google search and give you the information about that particular person based on object recognition. You have Google Lens, and then you have a headphone in your ears that can tell you, and you can listen to some audio without the person in front of you being able to listen. Then you have mic control, you can give voice commands. So I think those are all possible. And then the Iron Man suit is basically an exoskeleton, so it gives
yes.
Tony Stark incredible strength and agility. And we recently we have seen examples where you have a battery pack that's it's like a rocket pack on your shoulders that propels human beings in the air. So you have that technology also that can lift you and fly you. I think one man recently attempted to cross the English Channel using some kind of propeller or something. Not sure exactly what the
Yes,
technology was.
yes, no, no, I see that. I see many videos. I actually subscribe to that company. I can't remember the name of the company now, but they are, propelling you to fly, and it is very amazing. And I think it's also being looked at the military use of that kind of
Yes.
technology. But I mean, obviously, military use aside, there could be a lot of other uses just for transport, if nothing else. But obviously at this point it's very, very expensive, but it is possible. It's possible, and it may not be as slick as we see in the movies, but it is a little bit bulky. But as the technology improves, it will get better and better. But it very much is all of the things that we saw Iron Man's technology are individually possible. So it just combining all together, it's not impossible at all. But yeah, so it's interesting how close we are to science fiction, really. I mean, in even in Iron Man is an exoskeleton, and in one of the other Avengers movies as well, the Hulk was wearing another exoskeleton made by Iron Man, because so this whole concept of exoskeleton is actually very powerful, because as humans we tend to solve our problems, while when we solve our problems, we're in our head thinking of ourselves as humans with our limbs and our shape. And a lot of the times the solution to the problem comes to us, but the solution involves being in our shape, or we see the solution from a
Yes.
first person perspective. And a robot can give you that first person perspective, yet while being a separate entity altogether. That is the coolest part of exoskeleton. And um, it could be a full body exoskeleton, and a lot of the times you see that they're like extensions of like just an arm, which is the robotic arm, which extends or even attaches to humans, like iRobot, that film where Will Smith
Yes.
had a robotic arm. So yeah, it's just so cool, and so far reaching, the technology of robotics. Because I at the start of this talk, I didn't think about robotics being in connected to prosthetics, but it is.
It
All the
is. It
prosthetics
is.
is our robots. So it's amazing how like spider webs, you can reach many different industries and many different technologies just by adding different things into robotics.
Absolutely. And I think, I mean, we talked about prosthetics and space research and assembly line, but then in military, people use robots to do reconnaissance missions. So if you want to send some, um, say, a robot in a very highly radioactive zone, then instead of sending a human being, it's better to send a robot. If you want to take pictures, etc., or if you want to have super soldiers who have exoskeleton and they can run faster, they can hit harder, they can lift heavy weights, then I think that's a very good application. Then you have in the medical industry, you have now surgical robots, so robots that perform surgeries by itself or using human control, so teleoperators. So suppose you're in one part of the world and there is a robot in another part of the world. So using the internet, the doctor can control or the surgeon can control the robotic arm or the robot itself to perform certain surgery. So that's an application. There are agricultural robots that can track the soil temperature and other soil contents, and then maybe plant seeds, etc. Then you have educational robots that teach people uh, through various action. You find educational robots in museums. You ask a question, they respond. Then we have teleconferencing robots where you actually talk to the robot, but the robot has a TV that is showing you the video. Say I'm talking to you, but you are now in a teleconferencing robot where I see your video. So yeah, and now you have nano robots, so that are at nanoscale that can go inside your body and do certain things. So, I mean, there are n number of applications with robotics and robots in general. And then, but I mean, for the benefit of our audience, we should also talk about the different types of robots and how actually to build a robot. So, do you want to lead on that?
Yeah, sure. I mean, when we talk about, I mean, we've kind of discussed different types there are already, but if if we were to sort of list down, there are like pre-programmed robot like in assembly line we've talked about, and then there are humanoid ones that we talked about that looks like human. Obviously, yeah, I mean, we said, I was saying that, evolution didn't potentially give us the best design, but actually, no. In millions years of, generations after generation, the design we have is pretty awesome. I mean, it has, made sure that we survived all of these years, in the face of all the problems and all the distractions and all the things like that. So yeah, human design is pretty good. It's not pretty good. It's a quite amazing design we have. So a humanoid robot is actually something definitely to go by. And I was watching some videos of some robots which are based, shown like humans, and they are performing really well, doing a lot of the
Yes.
tasks like jumping and
And even gestures like facial expressions. I think now we are at a stage where we have robots that mimic human emotion, mimic human gesture. They can move their eyelids, they can move their hands just like a human being.
Yes, yes, yes. So humanoid, and then there are autonomous robots, which are trying to solve a problem or perform a series of tasks autonomously without having to be controlled by humans. And then you mentioned teleoperated robots like drones, or like the mining robots I was talking about. You operate them from a distance, but yeah, you operate them nonetheless. And then there are exoskeletons where you sort of sit inside the robot itself. So yeah, these are all different kinds of robots there are, and it may not even be an exclusive list. But also, the things within this list can also be combined together to make even a cooler robot. Like it could be a teleoperated robot which is autonomous. That way, like I mean, yeah, I think Amazon's parcel delivery drones that we're talking about, they are teleoperated, but they could also be autonomous, to a certain degree. And then, it could be a humanoid robot, which is, autonomous as well. So yeah, there could be like various permutation and combination, and that's the beauty of technology. You basically combine, a few different things, and then you end up with something even cooler, and then you keep doing that, and then that you just making progress that way.
It's just like evolution. You're just combining so many problem-solving capabilities into one platform. And maybe I think a lot of times people think that will artificial intelligence ever be equivalent to general intelligence that we talk about in humans? And I think we are very close to it. Um, when I say
Well,
very close, it means not like in a year or two, maybe in a decade or so. But I think it's far more closer to us than we can imagine. And we keep thinking that okay, are there aliens? And who is God, etc. I think we are slowly becoming gods. Anything that we imagine, we are able to build it right now. And anything that we think an alien should have, we are creating it. So what is stopping us from becoming aliens to some other species? Maybe we don't have any other species in anywhere else in the universe, and maybe we will be the first explorers going out and then giving superpower abilities to other civilizations. Who knows?
absolutely. I mean, now that we're going to Mars, imagine this. I mean, imagine if we, took some bacteria or some living organism which are really tough, which can withstand a lot of adverse environment. and accidentally left some in Mars, and in and then they started the evolution process in Mars, and then they've evolved into something completely different, and then life starts from there. And also, I mean, yeah, is there life in other planets? I mean, I think obviously looking at the sheer amount of planets and solar system there are, it's everyone says that it's very likely that there are. But we also have to think about that, the 4.2 billion years the Earth has been around. I'm not really 100% sure
Yeah, I
about
think
that.
3 to 4 billion years and
Yeah.
13 to 14 billion years for the universe.
Yeah, so for Earth to be around, and the amount of time we've been around is like a split second if you compare
Yes,
the.
yes,
So
yes.
there could have been alien civilizations and everything, but it's difficult to say that the timing was right. Yeah, there is probably a very high possibility that there was alien life out there. Maybe there was civilization. Maybe they talked between planets and all, but maybe they came and gone, or maybe they haven't come yet. And also, when we look in the sky, we only see like billions of light years before what happened. We can't see what's happening right now. So maybe something, many things are happening right now, but we can't see
We can't
because
see because we are so far away. Yeah, you're right.
yeah,
So, I
the
mean,
damn light
time
is not
time is a
close enough.
very relative concept. I mean, we think time as an absolute concept, but it's very relative. As you mentioned, communicating with a Mars rover is it takes about 11 minutes,
Mhm.
and maybe sending information and then receiving feedback, it would take about half an hour. So if it takes half an hour to communicate at the speed of light with an object in Mars, imagine if you have to communicate with something outside our solar system, how much time and effort and energy it will take. So basically, we are limited by the speed of light, and that speed is very slow when you
Yeah,
compare it with the size of the universe.
yeah. Maybe. I mean, I know we are diversing a little bit, but maybe quantum mechanics, where electrons can appear from one place in space to another place instantly, and then if we can control where it appears, and then we could say Earth and Mars, and then we could probably have instant communication. But that's as we were saying, decades away. But yeah, no, coming back to artificial intelligence, yeah, I mean, there might be in a couple of decades artificial intelligence, as you were saying. But right now, the robots already supersedes humans. I mean, any like even basic robots is probably a lot stronger than a human.
Like a Boston Dynamics robot, right? Those
Yeah.
dogs that you see running around with human
Oh yeah.
beings, those are crazy. I mean, we'll share videos for that in the description below, and I think it's very important to understand that those robots, I mean, of course, they cannot do all the range of activities which a human can because they are still limited by their limbs and the functions and the features. You have to operate their battery, they need electrical power, they need programming, etc. So I mean those kind of limitations are still there because think of a human being, we can heal ourselves by taking food. So we take in food, using that energy we heal ourselves, so we are self-healing organisms. Robots are still not self-healing. Then we can retain information and then we can build on top of that information. So suppose I read a book, I read a line, I get inspired and I build something. Robots currently are not able to do that. And then using food, we fuel ourselves. So that also gives us energy and we can fuel ourselves endlessly and we can we can maybe live without food for a couple of days, maybe weeks. So yeah, robots still can't do many of these things which a human can, but definitely they are stronger. If there is a repetitive task, they can do it much faster and they have more accuracy. So whenever we try to write something, our hands shake. So we cannot control something with very high accuracy, but with a robotic limb, you can control that with a very high degree of accuracy. So where a surgeon would maybe shake with a knife while doing surgery, with a robotic arm, you can have precisely uh, the movement that you want, and that thereby reducing the area of a cut that's needed to do surgery, and also that it improves recovery time because then you need less time to recover from a small wound than from a bigger wound. So all these things have given us a lot of advantages, and I'm pretty sure that they will help in the future.
Yes, yes, absolutely. I mean, yeah, these are there are various aspects or ways where robots are already better than humans. But the only thing or the main thing is well, if you want to call it consciousness or the intent behind it. I mean, they don't have an intent or a generic intelligence, which is what you were saying that we might have in couple of decades. But yeah, I mean, it would be really cool to see, but at the same time, a lot of the times it's very scary to see because they're already so much better in all other aspects. As soon as they have their own mind, who knows what they would want with that mind? But
So
yeah,
I see that as evolution. When people ask what's the next evolution, I think machines are the next evolution. So
yes, yes,
so
that
so
could be.
if you think about survival, then what is something that can survive beyond humans? A machine. They can
Yeah,
they are built of materials that can last much longer. The only problem is they cannot heal themselves, they cannot think. But if you have all that thing like self-healing, artificial general intelligence, and they have enough fuel, say maybe nuclear reactor like arc reactor, in themselves, then what's stopping them to evolve and be the next species on this planet? Nothing, right? so
absolutely. I
so i
mean,
i feel that the next evolution, and a lot of times people think, oh, what's the evolution? So I think evolution is driving us to make a better version of ourselves, which is a machine. And maybe we'll, so Neuralink is there now, we can control external objects. So Elon Musk is working on that. What if we could download all our memories into a machine and they just live in that machine forever? I think that's the next step of evolution. We seem to deny it, but I think there's a very high chance that that will happen.
yeah, that could very well happen. I mean, it depends. I mean, there are a number of simultaneous advancements is going on in different technologies. So one thing could be that we, transform ourselves into robots. That could be one thing, and
Or we
one thing
can,
could be we, invent genetic, general intelligence AI robot, which will, which is, unknown what would happen. And there could be many, many things like that. It could also be that we kind of, instead of becoming a robot, we just upload ourselves into a big system, into a supercomputer where we live in a virtual world.
yes,
So it could be many things, and it's interesting which one comes into reality first, because based on the speed of each of these things, we could have a completely different life in 100 years. And then, speaking of technology, there are technology that are also working on, preventing aging. So it could just be
exactly. So
that
yeah, it could be
just
just
don't
that.
age.
It could be
So,
just that human beings don't want to be machines, but we develop a technology like nanobots inside our bodies that heal us constantly, that
mhm.
regenerate, that repair anything that is broken in our system. So we never age. And they give us superhuman strength. So maybe we don't need to be machines. We can still be human beings.
Yeah, yeah, absolutely. So this is. I mean, we can talk about this endlessly. I mean, all of these cool technologies there are and the implications of it. But yeah, the key thing to look at is which one of these technology advances to that level first, and that will decide the rest of our humanity and the future. But yeah, robotics is certainly playing a very important part in getting us there in any of these streams of technology. I mean, the main thing that we can do is keep improving, keep permutating and combining technologies, and keep coming up with more and more advanced and cooler things. A lot of the times we think, oh, there are some, we don't want to build cool things, we want to build efficient things. But a lot of the times, a cool thing could have a lot of efficiency that you're not seeing right now, but just do it because it's cool, and then you realize, oh, this can have so much usability as well. So yeah, definitely would encourage listeners and viewers to sort of think about cool things to do as well as things with user benefits.
Exactly. I think it's very important that I think with the advent of internet, the pace of the pace of growth has accelerated quite rapidly, because earlier you had human beings with limited information. Now everyone has access to information, and that information is getting so many ideas out of people's mind, and they are able to create something. Just looking at something on a YouTube video, you are able to build on top of it and create something else. And I think um, that's paced our growth of knowledge and growth of development. And you can see that there is a rapid progress now that's being made. uh, Earlier, the development, when I was young, the stage at which we were developing was a bit slow. So I was born in 84. Until about 2007, we didn't have a smartphone. And iPhone came out in 2007. And we are now in 2021. So from 84 to 2007, there was not much use of smartphones. But from 2007 to say about to 2020, 2020, 21, smartphones have just changed our lives. They have transformed our lives. In a matter of like just over a decade, in over a decade, we have gone from getting rid of calculators, getting rid of alarm clocks, getting rid of cameras, getting rid of many other
Use-
devices, and just having one single device. And that's also with the help of robotics, because we have been able to manufacture things at scale very rapidly with high quality and high efficiency.
Yeah, yeah, no, that is looking at technology and how it evolved is always fascinating, and I get so amazed with it. But yeah, I mean, robotics has also like gone through. I mean, if you think about just the evolution of robotics in media. So we started with C3PO and R2D2, our
Yes.
beloved characters that we grew up with, and then now there are exoskeletons like Iron Man, and the evolution of even the science fiction items are quite extraordinary. So yeah, it's just exciting times, and it's just exciting to wait and see what we come up with next.
Absolutely, and I think it's a good time to think about robotics. I mean, for the benefit of our audience, I mean, we have talked about various technologies in today's talk, and they are all actually quite related to our previous episodes as well. We have talked about drones in the past. We have talked about AI. We have talked about machine learning. We spoke with a founder of the founder of Raspberry Pi, and all that is actually bringing together and solving actually a lot of different problems. And if you can combine that, put it in a machine that can solve even bigger and more complex problems, then I think, yeah, that's what our intention is. And one of the reasons we are having this tech talk is also because there is so many technologies available today that many of us are not even aware of, and we want to bring that awareness to people that okay, these are the possibilities with this technology.
Yes, yes, absolutely. This was actually a very fun talk, exciting topic to talk about. Really enjoyed it. Hopefully, our audience would also benefit from all the information, and hopefully, we've encouraged people enough that they would probably start their own project, which might bring some sort of cool combination of things, and take us a little bit one step further. Uh, into the future. Do you have any last message for our audience?
No, just yeah, keep exploring, be curious, and I think human beings are very good problem solvers. So just s- try to keep finding new problems and trying to solve them with machines, with tools that are already available. And yeah, do subscribe to our podcast. Keep learning.
Absolutely. Yes, yes, very much so. I mean, one of the thing is, yeah, you might feel like you don't have the necessary knowledge or expertise, but I would strongly say that you do, or you don't need that much. You can just assemble all the things that are already created. But even if it is the case that you don't have enough time, effort, or budget to carry through a project, but you have seen a problem and you have thought of an idea, why not just at least publish it in a blog post, or anywhere where people are interested in that kind of tech community. so that your idea is out there and someone else might actually want to collaborate with you and bring your project into a reality. So I think the main thing I want to say is, if you have a problem and you have an idea to solve that problem, try to fix it yourself, and if not, then at least put your idea out there so other people can. So yeah, that was my message. Hopefully everyone had enjoyed the talk.
I would like Rinath to also post his ideas, because Rinath has a lot of ideas in his mind, but he doesn't share it. So Rinath, this is to you as well. Everyone is listening, so I want you to post your ideas as well, because I think you have some
Yeah,
cool ideas.
absolutely. No, I do have some idea which I had written down, but I never published it. But no, I am working on it. It's actually a good thing. Yeah, I mean, why not publish those ideas so someone else can probably work on it?
Yes.
Absolutely. No, you're right. I am gonna work on publishing them if I don't do anything with them. So yeah, no, thank you, Amit, for that. Yeah, so that's about it for robotics
Thank you,
today.
everyone.
Thank you very much, audience, and hope to see you guys again next week.
Take care.